Andre Castello, and the topic that I've chosen is the introduction of trees. So let's hop into the topic. So introduction. Trees are used to construct efficient algorithms for locating items in images. They can be used in algorithms such as Huffman coding that construct efficient code saving costs in data transmission and storage. Trees can be used to model procedures carried out using a sequence of decisions. Construction this model can help determine the computational complexity of algorithms based on a sequence of decisions such as sorting algorithms. So theorem 1, an undirected graph is a tree if and only if there is a unique sample path between any two of its vertices. So for our definition, a tree is connected in directed graph with no simple circles. Because a tree cannot have a simple circle, a tree cannot contain multiple edges or loops. Therefore, any tree must have a simple graph. So, like it said on the definition 1, it only have one root and it cannot loop. And all of the edges is directed away from the root. So definition 2. A hereditary tree is a tree in which one vertex has been designated as the root and every edge is directly away from it. Like I've said earlier, it only has one root and all of the edges of it is directly away from the root. So it cannot be looped back to the root. So as you can see in the examples, for our first example, it can be a tree because A and C can be the root. A can be the root, C can be the root. And all of the edges is directed away from the root. So for our second example is a tree because A is the root and all of its edges is directed away from the root. Next is C. C is the root for our third example. And all of its edges is directed away from the root. So for example 1, a tree is connected in directed graph with no simple circles. So C and D are trees because both are connected graphs with no simple circles. B is not a tree because EBADE is a simple circles in this graph. Finally, A is not a tree because it is not connected, which is it does not have only one root. So the terminology for tree suppose that T is rooted. 3. So FV is vertices in T other than the root. The presence of V in the unique vertex U such that there is directed edge from U to V. When U is the difference of V, V is called the triad of U. Vertices with the same parents are called siblings. The ancestor of a vertex other than the root are vertices in the paths from the root to this vertex, including the vertex itself and including the root. The descendants of a vertex or V are rooted vertices that have V as ancestors. A vertex of a tree is called a leaf. It has no children. Vertices that have children are called internal vertices root. It is an internal unless it is the only vertex in the graph in which it is a leaf. If A is a vertex in a tree, the subtree with A is the root in the subgraph of the tree consisting of A and its descendants and all edges incident to these descendants. So here's the example that it was referring to. So A is the root. The parents of C is B. The parents of Hij is G. The interval is B, C, G, H, and J. And the leaves is DEKLM. and the subtree of this is G. So, trees. An ordered rooted tree is a rooted tree where the children of each interval vertex are ordered. Ordered rooted trees are drawn so that the children of each interval vertex are shown in order from left to right. In an order binary tree, if an internal vertex has two children, the first child is called the left child. The second child is called the right child. The tree rooted at the left child of vertex is called the left subtree of this vertex, and the tree rooted at the right child of a vertex is called the right subtree of a vertex. The level of a vertex V in the rooted tree is in the length of the unique path from the root to this vertex. The level of the root is defined to be the zero. The height of a rooted tree is the maximum of the level vertices. In other words, the height of a rooted tree is the length of the longest path from root to any vertex. So, here's the next example. Let's say our root is A. What is the parents of CEF? So, the parent of CEF is B. What is the siblings of B? So, the sibling of B is J and K. What is the children of F? The children of F is G and I. What is the external nodes or leaves? So the leaves are all of at the bottom. D, H, I, M, and N. And J. What are the internals? So the internals are all of the inside. It is B, C, F, G, L, K. Depth level of G. So the depth level of G is the height. So depth level of A is 1, depth level of B is 2, depth level of F is 3, and the depth level of G is 4. Height of the tree. So we should count how high, how long, or what is the length of the tree. So 1, 2, 3, 4, 5. So the height of the tree is 5. So that will be all. Thank you.